In this video, I'm going to explain isotopes and how this relates to the relative atomic mass that one finds in the periodic table. So isotopes are the same type of element, same type of atom, but with a different amount of neutrons. That means that the mass number changes. We write different types of atoms as follows. We use the symbol, below the proton number, at the top the nucleon number or the mass number. Two examples here. We're going to use the example of chlorine to explain the relative atomic mass. Chlorine has a proton number of 17 and exists in two types, two isotopes, with a mass of 35 and a mass of 36. So one can work out the number of neutrons by subtracting 17 from 35. So 35 minus 17 is 18, 37 minus 17 is 20 neutrons. In nature, one finds, for the most part, for the biggest part, the chlorine 35. And for a smaller part, about 1/4, chlorine 37. So I've written this, I've copied that information in this table, and then we can use this information in a calculation of the relative mass. So the mass of these two are respectively 35 and 37. And for 75%, 75.5%, we have a mass of 35 for chlorine, and for 24.5%, we have a mass of 37. If we calculate this, we find that the relative mass, the average atomic mass, is 35.5, and that is almost, it's what we find in the periodic table here, 35.45. If we round that up, that's 35.5. So this already gives us a little explanation from the next unit, Unit 5, and it shows you why isotopes are important for us later on in the curriculum.